question number 27, which gives us this equation, 2 KClO3. Remember to write your L's like a cursive so you can not confuse it with iodine. 2 KCl3 oxygen gases. Okay? And it tells you to assume that the density of oxygen gas is 1.428 grams per liter. So part A wants to know the volume of oxygen if you have 5.00 times 10 to the negative 2 moles of KClO3. Okay, so looking at my balanced chemical equation, what am I trying to find if I'm asked for volume of oxygen gas? Which of these three things is my unknown? KClO3, KCl, or O2? What's my unknown? Okay, so I'm being asked to find the volume of O2. And what is my known?
KCl.
Okay, so I know I have 5 times 10 to the negative 2 moles. If I have times 10 to the negative 2 moles, do I have more or less than 1 mole? Because a negative exponent represents a number that is 2 decimal places less than 1, right? And is the question asking you anything about KCl? Okay, so which is my known? This is my known, so let's make this compound A and compound B. Okay, so now let's work out the problem. I have 5 times 10 to the negative 2 moles. If I want to make my life a little bit easier, can I go ahead and rewrite this in standard form? What's 5 with 2 decimal places less than 1? Okay, so take a look at this. This is a 5, 2 decimal places less than 1. Okay, so I have 0.05 moles of A, which is KClO3. Okay, and I'm asked to get into liters of oxygen gas. So if I'm in moles of KClO3, how do I go from moles of A to moles of B? I'm going to compare mole ratios of A to B using my mole ratio. So what's my mole ratio in this problem? 2 to 3. So I have 2 moles of KClO3. Okay, that's where this came from. For every 3 moles of oxygen gas. And I set it up that way so that moles of A cancel out moles of A on the bottom. Okay, so if I stop the calculation here, I've converted from moles of A into moles of B, okay, because I've canceled out moles of KClO3. But is the question here asking me to find my moles of O2? It's asking me to find the volume. So how do I go from moles to volume? I've got to take a step here. I've got to take 2 steps. I can convert from moles of oxygen gas into mass of oxygen gas. How do I find out how many grams there are in a mole of oxygen gas? Handy dandy periodic table. 1 mole of oxygen weighs how much? 16 grams. But I don't have oxygen. I have O2. So what's O2 if O is 16? Okay, so from my periodic table I found that I have 32 grams. Okay, remember that this is the molar mass of B from the periodic table. Okay, and I set it up this way so I can cancel out moles. And if I stop the calculation here, I have my mass of oxygen. Is the question asking me to find my mass of oxygen? It's asking me to find the volume of oxygen. So how do I go from mass to volume? How do I go from mass to volume? I use the density, because density allows you to convert from mass to volume, right? Grams to liters. So if I want to cancel out grams of O2, what needs to be on the bottom here? So up here needs to be liters, and my density tells me that there's 1.428 grams for every liter of oxygen. So now my grams cancel out, and my units will be liters of oxygen gas. Okay, so in order to solve this problem, I would multiply across the top. I've got 0.05 times 3 times 32 divided by 2 divided by 1.428. So let's bring out our calculator to calculate 0.05 times 3 times 32 divided by 2 divided by 1.428, and I get 1.68. And what are my units? Liters of oxygen gas. Remember to put a box around, circle, or highlight your final answer. Okay, so let's review the steps one more time just to make sure you see where all the numbers came from. We were given a balanced chemical equation, 2 KClO3, break down to 2 KCl's and 3 oxygen gases. Question asked you to find the volume of oxygen gas if you have 5 times 10 to the negative 2 moles of KClO3. So that's where these two red things came from.
Me too, Ramirez. Hi. Sure. Thanks.
Alright, so what we're going to do now is to take these pieces of information which are given to us in the problem, and we're eliminating KCl because the question is not asking anything about it. So start with your given amount, 5 times 10 to the negative 2 moles, which we converted to standard notation. Anytime you have a negative exponent, that means it's a number less than 1. For each number, it's a decimal factor of 10. So negative 2 means move the decimal back 2 factors of 10. So 5 times 10 to the negative 2 is the same as 0.05 moles. That saves us a little space, and it's easier for our brain to hold on to because it's a small enough number. Okay? So you have moles of A, and you want to find moles of B by comparing their mole ratio, which is 2 to 3. So you set up the 2 to 3 ratio, making sure you cancel out KClO3s. For moles of oxygen, you can use your periodic table to find the molar mass of oxygen gas. 16 times 2 is 32 grams of oxygen for 1 mole. Now moles have canceled out. And from grams, you can convert to liters by using the density given to you in the problem. You're told that the density of oxygen gas is 1.428 grams per liter. So 1.428 grams per liter, and you set it up so that grams of oxygen cancel out. You multiply across the top, 0.05 times 3 times 32, divide by the bottom, 2 and 1.428, and you get 1.68, and your units are liters of oxygen.